Alrighty then, corn children, children of the corn, it is the fascinating lesson on completing the square. Completing the square? Why would we ever need that? I am so glad you asked. One of the times that we will need to know how to complete the square is when, we want to put a parabola in vertex form. What's that? Here it is. This is the vertex form for a parabola, and if we have it in this form, we will know that the vertex is at the point H, K. Where's the square? I don't see it. Here it is. Oh, look at that. There is a square right there. So the vertex form has the x terms in a perfect square. When else? So glad you asked. If you want to know about a circle, standard form for a circle looks like this. No. Yeah, look at all the squares. There's a square here, here, and if you even want, you could write the radius as squared. Now, if these are unfamiliar with to you, go ahead, pause the video and get these jotted down. Better yet, even if they are familiar, pause the video and write them down. So this is the standard form for a circle, and the center of the circle is H and K, and the radius would be R. So if we're in this form, we can sketch a circle. If we're in this form, we can sketch the parabola. But unfortunately, not all equations are written in that form. So here's what we have. We have been asked to find the vertex for this here parabola. Yeah, it is a parabola. It has x squared as its highest term, but it's not in the perfect square form. So we need to complete the square in order to write it that way. All right, so here's your process. Feel free to slow it down, pause it, replay it over and over again. All right, first thing I want you to notice, this is an easy problem, and here's why. The coefficient on the squared term is a 1. When the coefficient on the squared term is a 1, it is so much easier. I'll do one here in a minute that isn't a 1. This one is. Now, because the squared term, the quadratic term, has a coefficient of 1, we get to skip a few steps and go immediately to the following. I'm going to take this constant term of 2, and I am going to move it out of my way. I'm moving it way over here. Now, you don't have to go that far. We didn't get rid of it, but I just want you to notice I'm not even looking at it. Stop looking. Stop it. Now, I am just looking at these terms right here. I would really love for these terms in the front to be a perfect square. In other words, I can backtrack that. I want it to factor into the exact same thing twice. So I need to know what number to put here so that it will factor perfectly into the same thing twice. Here's how we do it. Once you have a coefficient of 1 on your quadratic term, which we have, you look at the linear term, the plane x. You look at its coefficient. Its coefficient is -6. Are you looking at the -6 right there? We sing to it. What? Yes, here's your song. Divide by 2 and square it. Divide by 2 and square it. Yeah. -6 divided by 2. -3. -3 squared is 9. I am going to add a 9. No way. Now there's a small problem here. This is an equation. You cannot just go willy-nilly adding a 9 to only one side of the equation. That's crazy talk. So because I have put a +9 here, I did it. Yeah, that's right. I must also put the addition of 9 on the other side of the equation to balance the equation. Now, let's take a look at these three terms. These three terms, now that I have completed the square, should factor into the same thing twice. What? Factors of x squared, x and x. Factors of 9, 1, 9, 3, 3. They need to be the same sign, and they need to add up to a -6. I'm going to go with -3 and -3. Shut up. It factored into the same thing twice. One could say that these are x minus 3 squared. That's right. All right, so let's bring it all together. You remember this +2 that we were ignoring? bring it over. Remember that plus 9? There it is. Bringing it down, writing as a perfect square, bringing it down. So here's we go. I'm going to write this as x minus 3 squared. There's the plus 2. Now I'm going to bring the y, the 9 over here so that it is solved for y. Do you see what I did there? There it is. So here's my equation in vertex form. Well, I can look at that and I can tell you it's a parabola. It opens, because it's a positive 1, it opens upward, it's standard sized, and the vertex is 3, negative 7. I could sketch that if I really wanted to. I don't really want to, but I could. So that would be the point of that. All right, so what if it's not a coefficient of 1? This was a nice one because it had a 1. Oh no! This next example has a coefficient of negative 2. Much harder, but I'm going to go a little faster. Yeah, I know, crazy. Here we go. All right, so I'm going to take this plus 3. I'm going to put it way in the back. There it is. It's there, but I'm ignoring it. Now, from these two terms, I must factor out this negative 2. It doesn't matter what that number is at all. Whatever this number is, whatever the coefficient of the squared term is, that is what I will factor out of the x terms. I'm not looking at the 3. It's in the back. We're ignoring it. So factoring out from here, I get x squared. Now careful, positive 8, factor out the negative 2 becomes negative 4x. You'll also notice that I have left some room here, haven't I? That's because we need to complete the square. I'm going to take that negative 4 and I'm going to sing to it. Divide by 2 and square it. Divide by 2 and square it. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Now, if you've been paying attention, you might think to yourself that we should add 4 to the other side. After all, I put 1 here, I should put 1 there. And I say to you, no, no. What? By putting a plus 4 here, it's inside the parentheses. And there's a negative 2 times the parentheses. When I put this plus 4 here, it's really in value because of distribution a negative 8 on this side. Negative 2 times 4 is negative 8. When I put that 4 there, whoop, it became a negative 8 on this side. So I need to add a negative 8 to the other side. Didn't see that coming. That's why I have a job. All right, here we go. This is now a perfect square. If you do not believe me that this factors into the same thing twice, go ahead, take the time, pause the video, factor it out. It will factor into an x minus 2 times another x minus 2. In other words, x minus 2 squared. How do you know? Because I sang the magic song. That's what it does. All right, last step. Red Rover, let's bring the 8 over. It's a negative 8 on this side. It's a positive 8 over here. Hey, look, vertex form. So if I wanted to describe this, it opens downward because of the negative. It is a skinny parabola because of the vertical stretch, and it has a vertex at 2, 11. Opposite, same sign. Opposite sign, same sign. Hey, that's pretty cool. I know. All right, real quickly here, people. We're going to do the same thing with a circle. Quick like a bunny. All right, oops. All right, so the equation of our circle that we're going to be looking at is x squared, y squared, minus 6x plus 4y equals 12. And we want to write that in its standard form. Well, you'll notice, first of all, there are 2 variables. Step 1, put all the x terms together, just grouping them up, leave some room, put the y terms together. Leave some room, put the constant term on the other side. Here's the deal, people, we get to sing twice. I sing divide by 2 and square it to the negative 6. Divide by 2 and square it, I add 9. Other side, add 9. I sing to the linear term of the y's, the plain y. See that 4? Divide by 2 and square it. You get 4. Add 4. Add 4. I swear this will, oh, I'm missing a plus sign. I swear this will factor into the same thing twice. This will factor into the same thing twice. Over here, I add that up, that's 25. Here's what I know. This is a circle. The center is at 3, -2, opposite on both of those. 25 is 5 squared, so the radius is 5. Enjoy.